All right, today we're going to talk about solving quadratics by factoring. And the quadratics that we're going to talk about factoring are going to be in this form right here, x squared plus bx plus c, where you know that your a value, all right, is equal to 1, okay? In the next couple days, we're going to talk about solving quadratics by factoring, where your a value is not going to equal 1, but we'll get into that in the next lesson. So, solving quadratics, what I want to talk with you guys today about is this word called factoring, all right? Because that is an appropriate way when you have a quadratic trinomial or a quadratic binomial to go ahead and solve it in order to go ahead and find the roots or the zeros to your graph, okay? So when it comes to factoring, there's three different things that I want to show you to start off with. Number 1, 2, and 3 are all different examples that you can use different rules for. Okay, so when it comes to factoring, what happens is you always take this c term when you're in the form of x squared plus bx plus c, and you go ahead and you find the factors of it, the possible combinations. All right, so the factors of 21 are 1 times 21, and then you have 3 times 7. All right, now what we're trying to do is we're trying to find a possible combination of addition and subtraction so that we can get this number right here in the middle, this b term. Okay, so we're trying to get a plus 10. So using these factors right here, which one of them would get me to a plus 10? Well, a plus 3 and a plus 7 would equal a positive 10. So what we're going to do is we're going to break this quadratic trinomial into two linear binomials where you take this and you put an x here and you put an x here, which makes up your x squared term. And then you take this factor, plus 3, and then you take this factor and you put plus 7. All right. What we've done now is we went ahead and we have factored that quadratic trinomial into x plus 3 and then x plus 7. All right. So here's what I want you to notice. All right, let me erase something real quick. This right here, okay, inside of this quadratic trinomial, you have a plus sign and you have a plus sign. And you notice what happens here in your factored binomials is you have x plus 3, you have x plus 7. Okay, so I want you to know that if you have a plus and a plus, you're going to have a plus and a plus here. All right, let's try number 2. I'm going to take this c term out to the side, and I have a 14, and it's a negative 14. So my factors of 14 are 1 and 14, and then I have 2 and I have 7. Okay, now what we're trying to get in the middle here is we're trying to get a positive 5. So this is what we're working for right here, a positive 5. Well, how are you going to get a positive 5 using this? My thought is we would do a plus 7 and a minus 2. Because what is negative 2 plus 7? Well, that equals a positive 5. So now what we're going to do is we're going to break this one into my two binomials. I'm going to break up my y squared into y and y. And now I'm just going to take this first one here. I'm going to put it in parentheses. And I'm going to take this second one right here, the second factor. I'm going to go ahead and put it inside the parentheses. So in this one, when you factor it, you end up with y minus 2, all right, times y plus 7. Okay, now you'll notice what happened in this one. Let me erase again. Look at your operations in this one. You have a plus and you have a minus, and look what happens inside of your parentheses. You have a plus and you have a minus. Okay, so something to think about there. All right, last one to factor. We take out my c term. All right, we got number 12, and it's a positive 12. So I got 1 times 12, 2 times 6, and I have 3 times 4. So this time I have 3 sets of factors here. All right. We're trying to get in the middle here, we're trying to get a negative 7. All right. How would I get a negative 7 using one of these sets of factors? All right, well, we know that 3 plus 4 would give me a positive 7, and we know that a negative 3 and a negative 4, if you add those together, would give you a negative 7. So what I'm going to do is I'm going to break this up in my two binomials. I put an m in the first spot and an m in the first spot. All right, and then I take this and I put it here, so minus 3, and I take this factor and I put it here, and I got minus 4. Okay, so here's what I want you to recognize for this one. if you have a negative for your bx term, but you have a positive for your last term, you're going to end up with two negatives inside of your factored binomials. Okay? That's the way that I like to do it, guys. I like to take that c term out and go ahead and write in the factors. Some people will show you some tricks, a box or a factor fish or whatever they do. But I think just getting down to the basics, guys, of knowing your multiplication facts is the best way to do it. So, all right, this one right here, number 4, q squared minus 36. Now you notice this one is, all right, x squared plus bx, all right, plus c. Well, you got your q squared. You're missing your bx term, so it's almost like you have 0 x's. Or in this example, sorry, in this example, it's almost like you have 0 q's, right? So it's almost like you have q squared, right, plus 0q minus 36. All right, well, we would do this one the same way. We go ahead and we take my factors out. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now we're trying to get 0 in the middle. So which set of factors could get you to 0? Well, you could use a positive 6 minus 6. That would equal 0. All right, so for this one, if you go ahead and you break it up now into your two sets of parentheses, you put a q in the first spot and a q in the first spot. And then you put a plus 6 because you use this first, and then you put a minus 6. All right, so here's what I want you to recognize. This one right here, this one is known as the difference. All right, so this is known as the difference of two squares. All right, difference of two squares. All right, and whenever you have the difference of two squares, what you can do is you can take this first term right here, q squared, you can take the square root of it. Well, we know that q squared breaks up into q and q. And then you can go ahead and take the c term and you take the square root of that. What's the square root of 36? 6 and 6. So the difference of two squares is written as this. All right, a squared minus, and it says b squared, and it's always going to equal a plus b. All right, and then you have a minus b. So that's the rule right there for the difference of two squares. Okay, you just take the square root of the first term and the last term, and that is how you're going to go ahead and you're going to factor it so that you get 0 in the middle. Okay? Now, this one right here, this one is known as the perfect square, all right, perfect square trinomial. All right? For the perfect square trinomial, there is a rule to this one. I just prefer to go ahead and stick with the basics. Take all my factors of 81, right? 1 times 81. What else have we got for this? We got 3 times anything. I'm going to do 81 divided by 3, guys. 81 divided by 3. What does that give me? So we got 3 and 27. All right. What else do we got? 7. No, we're going to go with 9 and 9. All right. We're trying to get negative 18 in the middle. This one right here. If I did negative 9, add those together, I get negative 18. So for this one, when you go ahead and you do your, break this up, w and w, put your factors in, negative 9, negative 9. All right. This one, to rewrite it, it's known as this, w minus 9. Since there's the same exact thing inside of parentheses, you can just go ahead and say squared. All right. So whenever you have a perfect square trinomial, you end up with, whatever is in one binomial is the same thing in the other binomial, and then you can write it as squared. Okay? Now, one difference. This one right here says solve the following quadratic equations. And when we're solving quadratic equations, what we're going to find is we're going to find solutions that are known as your roots, all right, of the quadratic. Okay? So all you're going to do for this one is you're going to take and you're going to do the same thing. You're going to take out your c term. Forget about the 0. My factors of 4 are 1 and 4, 2 and 2. And we're trying to get this term in the middle. How would we get negative 4 Well, we'd go ahead and we'd use these two numbers, and I would put a minus 2. That gives me negative 4. Okay? So, let's go ahead and let's keep working here. All right? Two sets of parentheses, and all of this is equal to 0. You take and you put your x here, you put your x here, and you put your factors in. Minus 2, minus 2. Okay? Now what we're going to do is we're going to take and we're going to solve both of these to find our roots. So I'm going to break it into two separate equations. I got x minus 2 is equal to 0, and I got x minus 2 is equal to 0. I would add 2 here, I would add 2 here, and I'd end up with x is equal to 2. I'd do the same thing here, x plus 2, alright, and I'd end up with x is equal to 2. So you'll notice what happens is we end up with just one solution here since they're both the same. Okay? So this graph, if we were to go ahead and graph it, would end up with, let's see, do we want to graph this one? Let's go ahead and let me find my calculator real quick. Let's see how much time I got. Alright. Alright, so for that one, what did we have? We had x squared minus 4x plus 4. Alright, so I'm going to go ahead and I'm going to hit y equals here. I'm going to go ahead and I'm going to clear that. Alright, I'm going to go to x. I'm going to clear my inequalities. Alright, I'm going to hit alpha. Alright, I'm going to enter. I'm going to clear those. Alright, forget it. Just going to go with alpha f1. Alright. We had x squared. Alright, minus 4x plus 4. Plus 4. Let's go ahead and let's hit graph. And this one, what will happen is you'll notice that your parabola only touches your graph at exactly one point right there. And that point is 2. Okay? So that's how you go ahead and you find the roots of these ones. The last part of that I want you guys to know for this is finding the zeros of a function. Alright, and that's by rewriting it into intercept form. And remember, intercept form was this: y equals a, and then you got x minus p, and then you got x minus q, where your p and your q, your p and your q, those are going to be your roots. Okay? So the same idea here. Instead of it setting it equal to 0, what we're going to do is we're going to set it equal to y. So now it's a function, but we're still going to factor it. Factors of 15, 1 and 15, all right? And then you got 3 and you got 5. We want to get 8 in the middle. So I'm going to say that y is equal to x plus 3, and then you got x plus 5. All right? So in this one, if you want to find your zeros, all right, you end up with 1, 0, where you have x is equal to negative 3. And then this one, you end up with x is equal to negative 5. So your zeros for this one are going to be negative 3, comma, negative 5. Okay? So it's the same idea when you're finding zeros. You're still factoring and doing all that kind of stuff. It's just a different name because you're now in function notation. Whereas up here, you were finding the roots to the quadratic equations because all of these right here were set equal to 0. Okay? We're going to get in more into factoring. And tomorrow we're going to talk about the ones where you actually have an a value, where instead of this being 1 right here, it's like a number 3, and then you got to factor both the a and the c values. Okay?